All right, now this will be quite familiar to those of you who do science. We're going to have a look at how we can link distance or displacement with velocity or speed and acceleration. All right, now we won't go into the details, but distance and displacement are not quite the same thing. Those of you that do science will know, and even our math students should know, that distance is how far you travel in total, whereas displacement is the total distance from where you started. Now, what we usually do is for an equation for distance or displacement, we call that equation S of t. Right. Now, if I get the derivative of my distance or displacement equation, then that equation will give me an equation that describes the velocity or the speed at any given point. So now I'm going to write speed or velocity, and speed or velocity is then the derivative of my distance or displacement equation, and the speed or the velocity equation we usually call v of t. There's then also a way for me to get from speed or velocity to acceleration. Just extend my page a little bit there. Acceleration is then either the second derivative of my initial of my initial distance or displacement equation, or it's equivalent to the first derivative of my speed or velocity equation, and that can then be called A of t. All right, so let's just make a quick summary. If we have a look at S is our distance or our displacement. Our distance or displacement is usually measured in meters. Then I get velocity or speed, which is measured in meters per second. And then it is acceleration, which is meters per second squared. Now, what this means is if I have a graph where on the y-axis S or distance is shown, and on the x-axis time is shown. If I take the gradient at any particular point of my S to t graph, that will give me the velocity or the speed. Again, if I have a graph of velocity on the y-axis and time on the x-axis, and I take the gradient of that graph at any particular point, that will be my acceleration. Right, perhaps the explanation sounds a little bit more complicated than it is, but let's just quickly have a look at just a nice simple example. The question will usually start out with giving you S. So in this particular instance, it says that the displacement of a particle is given by S is equal to 3t squared. All right. Now let's have a look at a possible question. So the displacement S is 3t squared. They could ask me, what is the displacement after 2 seconds? Displacement at t is equal to 2. Right, then I say to myself, I do have a displacement equation, and I'm simply going to substitute 2 in the place of t. And if the displacement was in meters, then this will then be 12. 2 squared multiplied by 3, 12 meters. Then they could ask me, what is the velocity after 2 seconds? What is the velocity after 2 seconds? Now I have a look and I say, at this stage, I do not have an equation that describes the velocity, but I do know that the first derivative of the displacement gives me the velocity. So then I'm going to say, right, S dash t, that is the derivative of the displacement, which is the same as the velocity at any given time. I'm now taking the derivative of 3t squared, and that gives me 6t. So my velocity is described by the equation 6 times t, and if I then want to know what is the velocity at 2 seconds, I'm quite simply going to substitute 2 in the place of t, and that gives me 6 times 2, which is 12 meters per second. Another possible question could be to calculate the acceleration. Now, in this particular case, what you will notice is if I take the derivative of my velocity equation, there's my velocity equation. The derivative of my velocity equation will be 6. Now that means, that gives me a constant. So that means that my acceleration, irrespective of what the time is, will be 6, and that is then meters per second squared. All right, so just quickly, we can start with displacement or distance, that is S. The derivative of displacement or distance gives me velocity or speed, that is V. And if I then take the derivative yet another time, I end up with an equation for acceleration at any given time.
Keep that frequency clear. Keep that frequency clear.